tonight. 지금 당장 날 봐. 시간 없잖아. 넌 내 거야. 이미 알고 있잖아. Cause I need you to need me. I make me feel so refreshing. My little soda pop.
This experiment investigated how pressure acts on a flat surface submerged in a fluid. As a depth increases, the pressure also increases, creating a moment or turning effect around a pivot. The point where the total pressure force acts is called the center of pressure. This experiment is important for understanding how fluid force work on structures like dams, gates, and tanks. The objective is to find the experimental center of pressure, compare it with the theoretical value, and understand how pressure is distributed on submerged surface. First thing first, measure the width and depth of rectangular face of toy rod. Secondly, measure the length from pivot to load hanger.
Step number 3. Adjust the 3-foot screws until the apparatus is balanced. This will be indicated by the spirit level situated on the left side of the apparatus. Step number 4. Using the rider, adjust balance arm until it is level.
Next, we fill the tank with water to the zero scale datum. Just touch the base of the rectangular face of the toroid and can be adjusted by opening or closing the outlet valve. And then again, fill the tank with water to a certain level.
Next, place weight on the load hanger to restore the balance arm to the horizontal position, and then record the weight on the hanger and measure Y2.
Lastly, repeat for 3 other values of Y2.
So this is the table of the result and analysis data. We have taken the 3 reading, which is the 1 Newton, 2 Newton, and 3 Newton. The result of depth of immersion is 0.066, 0.096, and also 0.12. First, we need to measure the area. Next, we need to calculate the hydrostatic force. After that, we need to calculate the find moment of inertia, which is IT. And then we need to calculate the theoretical depth and also the experimental depth, which is the center depth of pressure. And lastly, we need to calculate the percentage of error from the theoretical depth and also experimental depth. So this is the example of the calculation. First, we need to find the area. Next, Hg. After that, hydrostatic force, value of y, value of y1, value of moment of inertia, value of theoretical depth, value of experimental depth, and lastly, this is the final error.
In this experiment, we investigate the center of pressure on a submerged surface using 3 different applied weights: 1 Newton, 2 Newton, and 3 Newton. As the weight increased, the depth of immersion also increased, which affected the pressure distribution. We calculate both the theoretical and experimental center of pressure. At 1 Newton, the percentage error was quite high, around 56%, likely due to smaller force being more sensitive to error. However, as we increase the weight to 2 Newton and then 3 Newton, the result become more accurate. At 3 Newton, the error dropped to just 2%, showing that higher weight give more stable and reliable measurements for the center of pressure.
Conclusion. In conclusion, the experiment successfully demonstrated the relationship between applied weight and the accuracy of determining the center of pressure on a submerged surface. It was observed that as the applied weight increased from 1 Newton to 3 Newton, the depth of immersion also increased, leading to a more stable pressure distribution. The percentage error was highest at 1 Newton, likely due to the greater sensitivity of smaller forces to measurement errors. However, with increased weight of 2 Newton and 3 Newton, the experimental results show improved accuracy, with the error reducing significantly to as low as 2% at 3 Newton. This indicated that higher applied weights provided more reliable and consistent measurements for calculating the center of pressure.